Okay, good morning. Glad you're joining me this morning to talk a little bit about exceptions in Python. Again, they asked me to put this slide at the front, and I do what I'm told, so there you go. Rate the session. So to introduce myself a little bit, I'm Naomi Ceder. I am, among other things, the currently serving chair of the Python Software Foundation. I do tell people that sounds maybe a little bit more glamorous than it actually is. PSF manages the intellectual property of Python. Somebody has to hold all of it so that it can actually be ensured to be open and free and things like that. We look after trademarks. But also, more important than that, we work on trying to grow an inclusive global community of Python developers. That's what we spend a lot of our time on. And in fact, tomorrow, I go to Cleveland for PyCon, which is our big gathering. So looking forward to that. I'm also the author of the Quick Python book, now in its 3rd edition. We have a few copies to give away, and I will sign. I promise I will sign it with any name you want, Bill Gates, whatever you want. It'll be straight down here across in the expo hall, right beside the Women in Tech area. So right as you walk in on this side, just right over to the right. So we'll be doing that. And if you have any questions that we don't have time for here, you can, of course, hit me up there. I'm also, in my day job, I run a development team. We code mostly in Python for Dick Blick art materials. Yes, art supplies. So if you've bought erasers, pens, paint, pencils, canvas, any of those things from us in any of our stores across the country, that's where I work. I actually like working there. It's a nice medium-sized business, and I enjoy it a lot. So that's that introduction. The other introduction has to do with, I guess, kind of my thinking as I approach this talk. And for that, I have to say that I have always been a language nerd. I have a PhD in Greek and Latin language and literature. So I have done these things from a very long time. Unlike the speaker yesterday who was talking about kind of programming from a linguistic aspect, I did historical linguistics as part of that. So I can talk about Proto-Indo-European and laryngeals and fun stuff like that. But I also am interested in modern languages. Actually, just a few months ago, I gave my first talk in Spanish. So I am a language nerd, but not just human languages. I also am kind of interested in computer languages too. My main language is Python. I don't see myself ever abandoning it, but I am curious as to how different languages work compared to each other. And with human languages, of course, every language has its own way of doing things, its own way of expressing things. For example, in, say, Japanese, a lot of things aren't gendered. They don't actually gender nouns. It's not a big deal in Japanese. They have other ways of indicating that. On the other hand, in, say, Thai, you have a little particle that you say that varies depending upon the gender of the speaker. Not the thing being talked about, but the person doing the talking. And of course, something like Spanish has genders all over the place. They're usually pretty easy to figure out. And then German has a neuter knife, a feminine fork, and a masculine spoon, and you just have to know that. Okay, so a lot of different ways of doing kind of the same thing. And it's not just simple things like vocabulary, it's the way the language is put together. If you want an entertaining illustration of this, I recommend you Google Translate Sings. This is a woman who's a professional singer who runs popular song lyrics through Google Translate through about half a dozen languages to get back to English, and then tries to sing the result to the original tune. It's okay, after a couple you get the idea and maybe the joy wears off, but the first couple, really, it strikes you as pretty funny. So, computer languages obviously aren't anywhere near as complex as human languages. For one thing, they're constrained by having to compile to a pretty much deterministic same result, something that can be, run ultimately by a microprocessor that is a fairly simple-minded beast. But it is still true that the structures of the language control how you think about and how you express yourself in a programming language. It controls, in a way, how you approach the problem. And so then my jumping off point from this is the situation of when things go wrong. If you write code, things go wrong. That is inevitable. It happens to everybody. There can be bad values entered by a user or some other way. There can be bad logic. Resources that you're counting on having might be unavailable. Any number of things can go wrong. And different languages tend to think about stuff going wrong in different ways. And in some cases, they try to categorize into compile time errors versus runtime errors, things like that. Or maybe there are errors that are we just have to blow up because there's no way we can go on. Or maybe there are errors that, no, we can recover, we can save this, we can do something to keep the program running. There are a lot of different things that you can do to think about errors, handling things that are unexpected. And that is, in fact, a key part of what makes a language what it is. It kind of controls how you do things, how you think about things in lots of subtle ways. And it certainly influences the structure and the flow of the code one way or another. So just to look at a few of these, and I've got some samples here to just kind of bring these up. I'm not saying that any of these little short snippets are an authoritative description of how they handle errors in that particular language. I'm just kind of throwing some things out here to set the stage. So Perl I always think of as the do or die language because of this idiom that used to be quite popular. Do the thing or die. Die if you can't do the thing. There are other ways you could handle errors in Perl, but this is quite a common one. C, I started C, I was just thinking about this before the talk started. I started coding in C 30 years ago, which means I did it when I was 2, right? But I was precocious. But in any case, there are different things you can do to try and catch error conditions in C. You can check for a return value. If you're trying to allocate some memory, it comes back null. That probably means you've got a problem. You can look at an error number. It's a global, a global error number to check what's going on. You can kind of jump off, set a jumping point, and jump off to some other place in the code that's sometimes done. Or the time-honored way of handling errors in C is to get a seg fault. And if you've coded much C, you are familiar with that. C++ adds an exception handling thing, but it's not, I guess my sense, and I haven't done C in many years, but my sense is that in C++, the use of exceptions, it's there. Certainly it's used, but it's not sort of woven through the language. That's my opinion. There's a lot of other approaches to handling errors other than exceptions. Same thing with Java. Java has certainly a system of exceptions, but there's also, it seems to me, a tendency in Java code to check first. That's when I talk about LBYL, checking look before you leap. Can I do the thing? Okay, let's do the thing. Java also, of course, has this kind of split between exceptions you have to talk about and exceptions you don't have to talk about in advance. So in this particular snippet here, it's worried about an I/O exception. With I/O exceptions, either your method has to upfront say it's going to throw an I/O exception, or you need to be sure that it's explicitly handled. There are other types of exceptions in Java where you don't have to do that. JavaScript, Okay, as a Python person, you're probably expecting me to crack on JavaScript. I promise I won't. JavaScript has 6 native types of exceptions. They're fine. But in fact, you don't need to do them. You can actually throw anything as an exception. So in fact, you can throw an error or you can throw true. And JavaScript is fine either way. So it's got an exception system, and I think that it is used quite a bit, but that's what it is. Go actually returns 2 things from a method or function. It returns the result, and it can return an error value. So in Go, you can find error code like this, where check the one thing is your thing, or you can check the error to see if there's an error, and you get this kind of parallel thing like this. I know of people that find this to be a good system because it's very explicit. I also know of Python programmers moving to Go who find it very frustrating. I am not a Go expert, so I'm out of this argument, but that's what it is. It's just a different approach. And as I say, all of these things are based on different assumptions, different beliefs about how the language should behave, what it should do, and they shape very fundamentally the kind of code that you can get back. So, what about Python? So I want to start, before I get into some of the further things about it, I want to walk really quickly through Python's exception system, because my sense is there are, in a conference like this, there are people who maybe know a little Python but don't know a whole lot of Python. I want us to kind of see what's really there before I go talk about the sort of interesting things more around the edges. So Python has an approach of handling errors rather than trying to avoid errors. And in the Python world, we talk about this as easier to ask for forgiveness than permission. If you want to do the thing, in Python, typically, you don't check to see if you have the right type, the right situation, the right whatever to do the thing. In Python, you do the thing and then handle the exception afterwards. Okay? That is fundamentally the way Python does it, and that is in contrast with languages that are much more worried about being sure you can do the thing before you do the thing. In other words, they tend to look before you leap. All right, in Python, this approach makes a lot of sense. Python emphasizes readability, and not having a lot of checks for things before you do things makes the code simpler and easier to read. Python is a fan of duck typing, and it binds its variables to objects late. So while Python is a strongly typed language, just by looking at a particular variable name, that is not itself particularly strongly typed. So all of those things mean there are lots of situations where, particularly if you wanted to check to make sure you have a legal type before you do the thing, does not make nearly as much sense in Python as trying to do the thing and then seeing what we have happen after that. Okay? And Python's exception system is pretty straightforward. You have a try statement followed by the block of code where you might expect this exception to occur. You have an except statement where you can specify what particular exception you want to catch and even give it a variable name, typically E. So that's catch exception as E, gives us the variable E as a handle to that exception object down in the except block. You can have an else clause for what to do if there is no exception. Okay, you don't always need to do that. You could always just have it outside of the whole try except block, but you can do it. And there is a finally clause of code that will always be executed whether you have an exception or not. Okay, maybe for a file operation, you want to make sure the file is always closed, use cases like that. So you have something that will happen no matter what. And of course, like most languages that have exceptions, you can deliberately raise an exception And for that, you use the raise keyword, and you must, all exceptions in Python must be a subclass of base exception. It didn't used to be that way, but it's that way now. So you cannot do other things other than raise some sort of exception class. So I've got, perhaps it's not exciting, but at least this gives you the enjoyment of seeing whether or not I make typos. But I want to run a little bit of code to show this live. And so, you know, a simple case here, I've got, let's go ahead and run this. So I've got a try block that just prints. It's not likely to make an exception, I admit. An except block if we get an exception, an else block for the other case, and a finally for the case that always executes. And it did what it was supposed to do. Now, if I raise an exception in my try block, that's going to change what it does. And in this particular case, then, it's going to say, oh no, you ran the exception. You don't run the else, but you always run the finally. Again, this is not, that's just kind of meant to get us started in understanding the way that this system works. So exceptions themselves became classes more than 20 years ago. That was in Python 1.5. Since Python 3, one of the changes that they made was to make it mandatory if you were going to raise an exception that it had to be a subclass of base exception. It had to be in that hierarchy. And by and large, most exceptions are subclasses of exception. So basically the hierarchy goes base exception, exception, almost everything else. Okay. The things that are not subclasses of exception are sort of separated out for a reason, and that is if you just have a bare except keyword and you don't specify what you're looking for, okay, for one thing, I'm going to argue later on, that's not a smart thing to do, but if in fact you do it for whatever reason, it will catch exception and all of its subclasses. And if there is a lot of code still floating around out there that does this, but maybe still wants to allow people to do Control-C to break out of the code or something like that. Okay, or maybe wants to exit out of the code. Some other things that you'll see. There are cases where you wouldn't want that kind of except catching all exceptions to catch those things. Those three things, system exit, exit generator, and keyboard interrupt, then are themselves out of the main hierarchy. They're descendants of base exception, but they're not part of the main hierarchy. So this ability, though, to subclass exceptions means that in Python you can create an endless and very precise hierarchy of exceptions if you need to. So I want to talk about that just a little bit as we go ahead. But first, here's what happens if you try to raise something that is an exception. No surprise. And here is, and yes, you have to memorize this. There's going to be a quiz in 5 minutes. This is the exception hierarchy in Python. This comes straight from the standard documentation. So that's what I was talking about. System exit, keyboard interrupt, and generator exit are on their own. Exception then has pretty much everything under it. And everything is a reasonably large list. Okay, you got that? Okay. Like I said, we'll have a quiz. So being able to have that kind of hierarchy is nice. Being able to subclass means, though, that you can, in fact, create your own special exception for a particular module or library that you're creating so that you can specify this as much as you want. And in fact, most large libraries will end up doing this. They'll have their own system of exceptions. And it's really handy maybe if you've got some sort of long, complicated process or whatever, to be able to know based on the exception at a glance, oh, well, this had to be here because that's the only place that those exceptions happen. Something like that. So it allows you a certain degree of precision, of ability to handle things. And this would be kind of an example of that. So let me get this straightened out a little bit. All right, so what I've done here, this is a completely silly example, but I've created a couple of custom subclassed exceptions, my special exception and my even more special exception. So we've got a hierarchy there. My special exception inherits from exception. My even more special exception inherits from my special exception. So if, let me change this around a little bit. Right now, I'm trapping only the most specialized case of that. And that means that if I were to, say, raise just a plain old exception, this particular except clause is not going to do anything with it. It will pass right on through. Of course, since nothing else is handling it, it bubbles up and says, "Bah, trace back," all of that. Okay. On the other hand, if I were to not raise that exception, but I were to raise my specialized one, then my handler catches it and just prints out what it is, and we don't have anything else there, right? And of course, if I were to do this one, quick check, what's going to happen? It's not going to be caught because it isn't that special exception. Okay? If I were trapping just my special exception down there, I would catch both it and its subclass, but since I'm only looking for the subclass, that's all I get. So as I say, point mainly being that you have this ability to trap things precisely. Actually, let me go back for a second here. And of course, you can do multiple excepts in a row so that you can sort of do this thing for that, do the other thing for the other condition, another thing for another condition, as many of them as you want. You can trap 2 or 3 different kinds of exception in the same except clause. So I want this, comma that, comma that. You can do those various things so that you have control over what is done for each particular exception. So that's great. And this ability, Python is really easy to extend, so this means that people love to extend it. So this ability means that you can make exceptions anywhere you want, because remember back there, all I did was just inherit from a parent type of exception and say pass. I didn't have to define anything because all of the exceptionness is baked in. So it's really easy to define them. So you'll find sometimes that people like to do a lot of them in their libraries and all of that. And there are kind of 2 schools of thought, and I have to admit I'm on the grumpy old person side. And that is, I say, be a little bit careful about that. You really need to go for what's convenient, readable, what works, what functions, rather than following the rule, every time I make a module, I must make my own custom exceptions because I think that's what I'm supposed to do. Because if you are adding all of those custom exception types, that's fine. But then if somebody wants to actually catch that exception, if it's actually going to be raised outside of the module or library you've created, they have to know exactly where it is in that whole module hierarchy and explicitly import it so that they can handle it. Okay? I mean, it'll work, it'll throw and give a traceback and all of that, but if they want to catch it, then the client needs to know where it is and be sure to get it. So that's kind of the trade-off between endless specified exceptions. And in general, I think the other thing is that a large amount of the time, one of the existing exceptions with a customized message, you can put a message or parameter in when you're raising an exception, will actually get the job done just as well. I mean, it may be that you have a library that specifically needs bad URL error. Could be. On the other hand, maybe you just need a value error with the message bad URL. So again, I'm in most of these things, my approach to being Pythonic is to argue to be a little bit more on the conservative side. But there are people who are big fans of the other one. So, few observations at this point. Python has, obviously, a very rich, well-developed system of exceptions. I hope you believe that now. And you can do very granular, specific exceptions. You can have a hierarchy of exceptions. And all of this works with Python because it's an interpreted language, and it's just the way that it works makes it suited to use and to recover from exceptions a little bit more than maybe a compiled language would. I wouldn't press that too far, by the way. But in general, for Python, let's say, it is happy with exceptions. And this comes to kind of the main takeaway. What actually led to the idea for this talk months ago was a code review on my team where somebody was doing a whole lot of type checking. And as we were doing code review, those of us who are more senior said, don't do that, it's not Pythonic. And he's like, why? So that kind of led to the discussions that were the beginning of this talk. So in general, handling an exception is probably more Pythonic than checking in advance. Not always, your mileage may vary, insert all of the standard disclaimers, but in general, handling the exception is the way that Python would tend to do it. Particularly if, of course, you're expecting the occurrence of that particular exception to be, well, exceptional. It wouldn't be a good idea to use exceptions to handle something that happens a lot. It's a good idea to use exceptions, particularly if you kind of know what case it is you're looking for and are able to handle it. And finally, like the ultimate thing is use the exception if it does, in fact, make your code easier to read. Okay, I would argue that in the vast, vast majority of cases, it probably will make your code easier to read. But Zen of Python says practicality beats purity. So if, in fact, there is a case where it doesn't work, then don't do it. Okay? So as an example, this is a completely imaginary example from a completely imaginary data system that behaves the way I want it to, so you can't argue with me. And let's say we're actually getting we're looking at a bunch of things from doing a bunch of queries on a database, and if we get back a null result, we don't want to do anything, but otherwise we want to print something out. Or do something else. I don't have a whole lot of space, but you know what I mean. So we get the result. If it's not none, we do the thing. Otherwise, we continue. Or maybe we say, if result would be maybe a little bit more Pythonic, if we knew that we could count on never getting zeros or empty objects back or something like that, there'd be different ways of doing it. But basically, we're checking to see what we get before we do the thing, right? Okay. And this was actually in the code review example, although it was much more complicated. But if you're doing this with exceptions, basically you can kind of collapse this all down into something that's a little bit simpler, and that is, let's go ahead and try to do the thing with the thing, and if not, we'll go ahead and just move on. So by putting that all on one line, I'm assuming if I get a none back, and I'm trying to print the count of my query result and it's none, it's going to tell me attribute. None object doesn't have an attribute called count. So in that particular case, since I know that my query results are going to be pretty much something like that, I can say, okay, I want to trap that particular error and just ignore it and move on. Okay? Now again, if performance was a big deal for me, and I expected to get nones back maybe 50, 60, 70% of the time, this might not be the way to go. Then again, I might be questioning my whole approach by that point. Okay? But that's a case. So basically, trying to avoid exceptions can sometimes get you into, is not the way that Python would do it. Let's put it that way. So far, I have argued that exceptions are wonderful. And they are, in fact. But they can be misused in various interesting ways. So these are things that you probably wouldn't want to do with exceptions. Real quickly, you don't want to have a bare except without specifying the type of exception, because that catches everything. And, well, except system exit, et cetera, those three exceptions. And it strikes me as very, very, very rare that you would want to handle all exceptions with exactly the same code. Unless maybe you just didn't like tracebacks and you wanted to have something that printed out something more polite than a traceback. But, if there is a case to do it, by all means do it. Even then, I would argue be explicit and say you're catching except. That will be a little bit more of a flag for people. So, like I say, this particular case, I only have 5 lines of code here. There are 2 or 3 errors that can happen, and just saying, oh, that's an error is not going to help anybody. So that's kind of the idea. Exceptions are wonderful, but I am not arguing that you need to use more and more and more and more and more of them. Obviously, too many exceptions can make your code a little bit tough to read. So, for example, this code has pretty much every possible thing wrapped in an exception, in a try except, I should say. It doesn't catch all possible exceptions, I'm not saying that, but every code is nicely insulated in a try except. And when I look at it, I wrote it and I have a hard time seeing what it's doing. Okay? So again, that's kind of against the pattern. You want to target your exceptions for them to make sense. Something else that I've sometimes seen is trying to wrap too big a chunk of code in a try except. Basically, you got this thing, a bunch of things might go on. Okay, so you don't want to have a whole lot of try excepts. Let's do one giant try and a whole bunch of excepts at the bottom. There are cases where maybe that's your only choice. But again, it makes the code a little bit hard to read in that you have this try, then you have some excepts down here at the bottom. And if I get a Unicode error, I need to go back up and try and see where it is in the code. I mean, of course, the traceback might tell me, but it's kind of hard to connect the two. So again, not particularly a Pythonic way to do exceptions. This one is my favorite. You can, of course, do try, except, pass. And I love this because one of the first times I was teaching Python, this is now like 18 years ago, I was teaching to a class of high school kids, and there were these 2 guys, and they had this look that teenage boys get when they think they're getting away with something, except it's not really working. And I didn't know what it was because they kept, any problem? Oh no, it's running fine, it's running fine, it's running fine. What they had done is basically wrapped everything in try, except, pass, try, except, pass, try, except, pass, because that meant they never got an error. Okay, it also meant their code did absolutely nothing and they had no idea of what to do. So yeah, it was basically, guys, take all of those out and let's actually make your code work, and then you can worry about using except. I know it's cool, but don't do that. So again, it's sort of, this thing is handy maybe in debugging, but this pattern, and I've seen it actually in production code occasionally, don't do that. So again, you're using exceptions, you kind of want to keep in mind how likely the exception is, what exactly it is you're expecting to go wrong and how you're going to handle it. And then, again, my personal prejudice, be a little bit parsimonious, be a little bit stingy about creating all sorts of exception hierarchies if you don't really need to. If you need to, by all means do. So all of that is kind of a gallop through the exception system. So now we're all exception experts, or at least aware of how it works. But it's not really what I thought was sort of the entertaining part of the talk. So in fact, exceptions aren't just for errors. And for this, we can thank the Harry Potter theory. The Harry Potter theory is something that Guido van Rossum, the creator of Python, came up with in a blog post now 15 years ago. And his point, he was reading the Harry Potter books at the time, and he was thinking about it, and he's like, you know, I know that when she wrote the first of the books, 7 books that she planned, I know that she knew the general outline that she was going to do. But I cannot believe that she knew every single plot turn and every single detail of how magic worked when she was writing the first book. And in fact, as Guido's theory goes on, she probably went back, when she was writing the later books, she probably went back and looked at some of the stuff in the early things and said, hey, I can use that detail in a way that will further my plot now, even though I didn't think of it back then. And what Guido is saying is that, in fact, in the evolution, the design of Python, there are all sorts of things that we do now routinely that he or anybody else never thought of that would be useful as features of the language in the way that they're currently used. So, you know, he says when he came up with the for loop, he hadn't thought of iterators or generators. He hadn't thought of using a percent for string formatting, or even the fact that in Python you use def to define both a function and a class and a method inside a class. You know, all of those things are great, but they were never actually part of the original plan for Python, which was, you know, now 30 years ago. So, in fact, there are some things that use exceptions that I'm wondering if you know about. Well, no, let me take that back. I'm banking on at least some of you not knowing about it. Otherwise, I'm going to have to kind of sneak out or whatever. But so I'm going to show you some pieces of code. They're all very simple. I'll give you a second to think about it and see if you can think of what exception is being raised. These are not, none of them really is a, quote, error. So in none of these cases would you typically see a traceback. These are cases where there is an exception and you may not know that it even happens. So, you can think about it. You don't need to shout it out or anything. There's no prizes, but so in fact, this import sys, sys.exit, it'd be the way you would end a program. If this were a program running like in a Unix shell, it would be indicating exit successful, no error, something like that. Okay? In fact, it is pretty much identical to raising the system exit error. And in fact, the interpreter does a little bit of, does catch that and do a little bit of cleanup at the end or whatever, but they are pretty much the same thing. And in fact, let me back up here. I'm in a Jupyter notebook, so of course it's got its own little rules about what you can and can't do in a Python subprocess. But if I run this one, it complains saying, yeah, there's an error, but it doesn't really exit. Of course, that would be bad because then my Jupyter notebook wouldn't be running. And when I do this, I get the same thing. I mean, as far as you can tell, see, it's raising that exception. So that's one that many people are not aware of. Next one. This is just iterating over a list. counting to 4. I mean, I'll run it. There you go. Okay, the exception there. Yeah, I know I've got a book signing. I told them. So, exception here, stop iteration. The Python iteration protocol, which is another fun subject that I've got to talk about that I at least find entertaining. The Python iteration protocol relies on the iterator raising stop iteration to tell the for loop it's done. It tells them that the iterator is exhausted. Now, there are some iterables that actually kind of rely on sequence semantics. I'll show you this right at the end. That is basically, they go 0, 1, 2, 3, whatever. That will actually also raise an index error to tell the iterator that it's done, which will then raise stop iteration. So you can get 2 for 1 there. But a list iterator is smarter than that and doesn't actually take that step. But it does raise stop iteration because that's how for loops work in Python. If you use a for loop, you're using exceptions. Okay? This one, well, and again, I hope I still got a text file here. Yeah, I do. So it's got a for loop, so we know it's got stop iteration, but there's another one here too. Again, think about it a little bit. Oops, let me move on. There's an end of file error that's raised. So if you're actually iterating, reading through a file, and you try to read at the end of the file, the file iterator, the file object rather, will raise an EOF error. If you've got a file iterator, it looks at the EOF error and says, oh, we're done. So it raises the stop iteration to tell the for loop it's exhausted and the loop has to end. Okay, this one is getting kind of into the weird and bizarre. Until I started digging into this, I wasn't aware of this one myself. So we've got a generator there, right? numgen is a generator function. It's got a yield in it. It's going to just spit back the numbers one at a time. Right? Every time it hits yield, that's going to kind of save the state of that object and return it to whatever was calling that particular function. So does that. And then down below, I've got a little for loop that just uses that generator object to get numbers and print them out, right? And here, let me do this. If I do that, it works. And everything you would expect to happen happens. Okay? We go through our yield. Once we're at the last one, it falls out, does a return, ends the generator, and all of that. And everything works just fine. The only exception we have there is the one that we get for stop iteration. Because generator objects are iterators, and they tell for loops to end exactly the same way. But suppose we break out of this loop before we're done, before the generator is used up, let's say. Get this. You'll notice that we didn't get this, the end of that for loop in the generator object, because that's kind of expected. But what actually we do get here as well is a generator exit exception. Why? Well, think about it a little bit. If we are iterating over the generator object that's created by calling numgen, it's saving state every time. You go back, get what's at yield, it saves its state, you go back, get what's at yield until it finally returns. And then, once it finally returns and once that for loop ends, that generator object we created by calling numgen in the first place is out of scope and can be garbage collected. But if we exit before we get to the end, if we don't do something about that, we have an object floating around there that is probably not eligible for garbage collection. And if we do that, oh, say, a million times, we just might develop a tiny memory leak. So in fact, when you actually break out, when that sort of object goes out of scope, even if it's not done, it will raise a generator exception, which basically triggers the cleanup. And inside of that generator function, you can trap it. So that is also a possibility that as something that you can trap. I do have kind of a complicated version where I have it trapped every place, but you can experiment with it. It's just an interesting, odd thing. If it ends normally, the generator exit is also raised, but it's sort of thrown away because it doesn't need to do anything. There's really no way to trap it then. So that's, oops, I didn't mean to change my code. Excuse me now, I'm falling apart. There we go. All right, let's move on. So yeah, that's the case with this one. So the generator closed, raises an exception. Okay, this one I've kind of given away a little bit. If you are looking for an attribute of an object in Python and it does not exist, actually, let me back up. If you're looking for an attribute of an object, you do object.foo, object.bar, object.but, whatever. What it does is it uses the dunder get attribute method to go and get that particular attribute for you, whether it's a reference to a method or it's a reference to some data, whatever it is. If in fact it cannot find it, if get attribute cannot find the thing you've asked for, it will raise an attribute error. Okay? If it raises an attribute error, the next thing that the machinery will do is check to see if you have a dunder get attr method defined. And if you do, it will then use that. And you have the option of maybe it's a data element that you want to calculate. Okay, you can calculate it and return it. Okay, so this is kind of a chain of things. So whether you know it or not, either way, you tend to end up using that mechanism if you actually are trying to define an attribute that is only calculated and doesn't really exist. So this is a little bit complicated, but basically when I run this, what happens is you try to get the attribute. If it's not there, in this case, I go ahead and print it out just to prove that I've been there, and then raise it again so that we can end up handing off to getAttr. That will then, is what happens only as a result, usually, of an attribute error being thrown. Okay, so what does this all mean? It means, in fact, Python uses exceptions as a form of flow control. If the condition is something that is exceptional, like it's the end of a state, we're signaling a transition, then exceptions are a way that Python, even behind the scenes, can use this as a means of flow control that, in fact, can make the code simpler. But I know a lot of people have a problem with using a lot of exceptions. They come from languages where this was frowned upon, and they feel like it must be somehow bad. And I want to reassure you that it is not particularly bad. If, in fact, you are at the point in Python where you are able to see these things, you should be seeing them as Pythonic. Understanding the exception system is relatively straightforward. It usually makes the rest of your code more readable. So, I guess what I'm saying is I don't buy the whole, oh, this is somehow confusing argument. Once you're used to it, it's not confusing. The other question is about exceptions being slow. And the thing is, exceptions are so rare that their being slow shouldn't matter. But if I'm slow, it will matter, so I'm going to talk really fast because we're almost out of time. Okay, I've got here a function that basically I created my own iterator. So it'll raise an index error to tell a for loop to raise stop iteration to end. So 2 exceptions. And I've got a little thing that tests it by squaring numbers. And then I've done the same thing with a while loop where I avoid all possible exceptions. Okay, Come on, come on, come on, we're running out of time. Oh. Oops, I didn't mean to do that twice. My bad. Okay. So if I do this same thing using this test count function, used a for loop and 2 exceptions. The while loop version did not use any exceptions at all, but is kind of like an anti-Pythonic pattern. You'll notice that the for loop version is 2 orders of magnitude faster than basically the version that works to avoid exceptions. Okay, that's kind of a weird example, and I can explain to you down at the book signing why that happens so extremely. But in general, the idea is don't work to avoid exceptions. They're Pythonic. Pythonic is better. Thank you very much. On time.